This is Ann Saterbak. I'm a faculty member at Duke University, and this video is about functional decomposition. Imagine that you were given the task of designing a spacesuit. That's a pretty big, complicated problem, and one that might require some decomposition. So one approach to decomposition is functional decomposition, where you think of the functions or actions that are needed. So if you think about a spacesuit, the spacesuit needs to keep the astronaut at a reasonable temperature. It needs to provide life support with oxygen and a way to capture the CO2. It needs to protect the astronaut from radiation. And it also needs to keep the astronaut at a reasonable pressure, because pressure in space is quite low. So functional decomposition, this is the process of breaking down an overall or a main function of a device, system, or process into smaller functions or subfunctions. So let's define what a function is. A function is a task or an action that is performed by a device, a system, or a process. And we're going to talk through this example with a toaster. So I ask, what is the main function of a toaster? It's to toast bread. Now, if you think about breaking these functions up into subfunctions, you might list a few more things. You might list that it holds the bread, or it desiccates the bread, or it warms the bread. Right, so these are subfunctions. And a subfunction is a function that has to work for a more general function to work. Right, so a toaster has to, in order to toast the bread, a toaster has to desiccate the bread, it has to warm the bread, it has to hold the bread in place. So when you're writing these functions and subfunctions, you often write them as verb-noun phrases, such as desiccate bread or warm bread. Right? It describes what the function does. And I want to be clear that it is not how it does the function. Right? That's what the design challenge is about. There are many ways to warm bread, right? You could put it outside in the sun. You could put it on a pan, right? You could put it in a toaster. So there are many ways to achieve that function, and that's what the design challenge is about. When you're doing functional decomposition, though, you're just writing out the functions in these verb-noun phrases. Now, there are many methods of decomposition. Shown here are three. The first is hierarchy, when you start with a main function and then you try to hierarchically break down those functions into subfunctions. Another strategy might be just to brainstorm as many functions as you can think of and write those down separately. A third way might be to generate many ideas, but kind of in a more web-like format. So you identify a function and then maybe a related function that you would connect that through a line. Right? Any of these methods can work for you, and I would encourage you to try them. I do want to compare and contrast a little bit of the hierarchy versus brainstorming. So when you're doing a hierarchy, it is very kind of strict and methodological, and you really need to stick with going along one branch. You kind of work your way down until you kind of dead end, and you can't think of any further subfunctions. When you brainstorm, you really use a more generative approach. You just think of anything that you can, and then you aggregate those functions together when you're finished. These two techniques can be complementary, so it might be useful to try one and the other. But in either case, you may still have some gaps that will require reflection towards the end. So let's talk about a range, right? So a range is when you have an oven on the bottom and a stove on the top. And we're going to focus in on the oven. So I completed a decomposition of an oven using both a hierarchy and a brainstorming technique. So on the left, you can see the decomposition for the oven using the hierarchy, where the main function is to cook food. And two subfunctions are to hold the food and also to warm the food. And then decomposing even farther for holding the food, you have to accept the food, support the food while it's cooking, and then present the food so the person can take it out. Under the warming food subfunction, There's this idea of increasing the temperature of the oven, maintaining that temperature, and then dropping that temperature back down to room temperature after the cooking is completed. So in contrast, when I did the brainstorming technique, I came up with a series of functions and subfunctions, including warming the food, regulating the temperature, placing the food, containing the food, insulating the space, and adjusting the temperature. Now, with the brainstormed ideas, I needed to aggregate those, and I found that I had 4 that were in the heating category, including warming, insulating, regulating, and adjusting the temperature. And I had only 2 that were in the more kind of structural area, around placing the food and presenting the food. So again, these had very kind of complementary results, maybe a little bit different. And again, by doing both, I was able to get a better understanding of the different functions that an oven has. So a second example would be to design an app. So many of you have probably used Grubhub or Uber Eats in order to order food from a restaurant and have it delivered. When I brainstormed some functions for creating an app, I had some ideas such as receive orders, confirm that the food is prepared, connecting with the restaurant, collecting money, connecting with the driver, and then confirming that the food had been delivered. I can imagine if you did this, you would come up with several others as well. Now, when thinking about developing an app, sometimes these main functions or subfunctions convert directly into algorithmic blocks. And so again, here's an example where functional decomposition can be very helpful. A third example is the design of toothpaste. You might list a number of functions that would be ideal for toothpaste, including preventing tartar buildup, preventing cavities, ideally reducing bad breath, and maybe whitening your teeth. So if you list up all of these different functions that you'd like in your toothpaste, these may associate directly with different chemicals or products that you put in the toothpaste. So again, going through this process of decomposition can drive the design of the toothpaste. So in all of these examples that we've talked about, identifying these functions drives the design. And again, in getting back with our astronaut, again, many of the things that you see in the astronaut suit, including the types of materials, the life support system on the back, those were all designed based on the functions that were identified that the astronaut suit must have. So as we end this video, just a few tips on functional decomposition. Like with many different forms of decomposition, it can be recursive. It may be iterative. You need to start and do it again, maybe later. You might ask the questions how and why in order to break down your functions into more subfunctions. And then finally, all of these identified functions and subfunctions, these are a place to launch the design of your product. So in summary, functional decomposition is the breakdown of functions of a device, system, or process into smaller functions. You can use functional decomposition to design a wide range of products, everything from astronaut suits, to toasters, to apps, to toothpaste.